All right. 3:10. Let's get started. Really quick, turn to the person next to you and tell them whether you thought yesterday's lecture was helpful. Nice. Cool. Okay. So some announcements. Congrats on finishing the midterm. Woo! And as you know, you have an opportunity to get some points back per yesterday's lecture. Stay tuned for a post about exactly how that's going to work. That's all I will say about that for now. But yeah, hopefully you found yesterday helpful. It was kind of an idea we came up with last minute. I think there's something really nice, maybe not nice, about knowing what the right answers are after you already took the test, but hopefully for your learning for this class, that was helpful. And also for getting points back. Homework 3, 2048 is due tonight. The latest you can submit using 2 slip days, if you have them left, is Friday. We're starting last section this week with Vedansh, and I won't be here this week, but I will be there normally. This is a really great opportunity if you feel behind. This is our halfway point. This is where you can get a fresh new start. We're going into Python, which is super exciting. So please take advantage of this. I think you will find it's really helpful for making sure you're solid on the material before moving on. Questions about that? We will put more out about the time it will be and stuff like that. I believe it'll be up this Friday. Okay, awesome. I won't be here next week. This doesn't really affect you much. Just putting it out there. Yeah. We're starting Python today, which is so exciting. This is my favorite part of the class. I hope you guys feel similarly. For me, this is like, I don't know if you were interested in the coding class because you watch hackers on TV and they look cool, but that's why I started coding. And this part really made me feel like I was a hacker or something. So hopefully you feel that way too. Snap doesn't super much feel like hacking, but Python feels a little bit more that way. Big credit to Josh Hug. So if you encounter his videos or you find him teaching another class, highly recommend. He's a fantastic professor. I stole his slides for today because I think they're really good for learning Python, and I hope you feel similarly. A couple of things. So your job today is not to learn Python entirely. I just want you to know it's going to be a little bit overwhelming because it's going to feel a little bit like we're relearning everything we've learned, which is not the case at all. But it might feel that way. It's not to take note of every single slide you see. I more want you to keep your eyes up here and make sure that you're kind of understanding what I'm saying to you. A lot of it is going to be, none of it is going to be terribly rough or hard to understand. It's more just transitioning into Python. Your job today is to take notes of differences you see between Python and Snap. That's really the biggest one. And then you will get some real hands-on practice in lab and discussion. So make sure you attend discussion today. Make sure you keep coming to lab. I think that's all I have for that. Oh yeah, and fill out the self-check. It's out now. So yeah. Any questions about any of that before I move on? Questions at all? Okay, let's get into it. So, oh yeah, I said that. So something about computational thinking. Okay, so the programming part of CS10, which has been the most of it, is not about learning Snap. That is not the point of this class. It's to learn computational thinking, which is far more important because it's going to span across, whatever you go on to do, all of your programming career. Okay, super important foundational stuff. So what are some of these things about computational thinking? So using abstraction, right? This idea that we can remove detail and provide generalization using parameters. Hopefully this one's familiar to you. Okay, that's a big one. Understanding the value of precise specification. What does that mean? So 2048 blocks, those were all custom blocks that you guys made, right? And that fit exactly the use case that we were trying to do to play 2048. Instead of using just the default Snap blocks, we built our own that worked exactly the way we wanted them to. So that's an example of that. Understanding the iterative design cycle. Across this class, this idea isn't super explicit, more implicit as we go. So we teach you about designing, prototyping your code, writing out an algorithm and implementing it, and also testing it, right? That was a big one. And lastly, thinking about how solutions scale. So this was in the form of algorithmic complexity. So we looked at how, as our input gets bigger, how our program gets slower. If it doesn't get a lot slower, that's really good. If it gets a lot slower, that's not very good, because we always want our solutions to scale really well. Questions about any of this? So these ideas here are the really big ones we want you to take away once you graduated from this class. Okay. So why are we learning Python? Why are we transitioning to Python? Why not C++? Why not Java? Why not Scala? Well, first of all, we're doing this transition period so that you can have a chance to translate your knowledge from Snap into a commonly used language. Okay. So Python is also used in 61A and Data 8 if you are curious. Those are definitely viable next options for you. Give some exposure to a text-based language in the accompanying workflow. So text-based language being one where we're typing on the keyboard and not dragging and dropping things like in Snap. What do I mean by workflow? How programs are written and executed. So in Snap, there was a certain workflow you went about that you probably implicitly picked up along the way. So this doesn't work, I'm going to try out different numbers in there. I'm going to drag and drop different blocks, things like that, right? This is also handy if you just want to use program for your own reasons. That's totally valid and fun. Also to expose some of Python's strengths. So there's a reason that there are different languages. I mean, if we wanted, there's like a lot of high power stuff we could just do with Snap. But there are reasons why we would also use something like Python or like Java or C++. Okay. So we have access to open source libraries. So hopefully you're familiar with the libraries on Snap, pretty similar. So it's that idea of abstraction, like I want to do really high power things. The great thing about that is that the programming world tends to be very collaborative. So people out there have written all kinds of code that will do very extensive things for you without you having to code it from scratch. That's when we take advantage of libraries. Okay, very important. Simple, beautiful syntax. I think that you might find, if you're like me, that you really enjoy Python. Some people prefer Snap. And for this reason, you will have the option to do Snap or Python for your final project, which will be your choice. More on that soon. And then also get a sense of what other languages do. So Snap is really high power, as we've said, but there are definitely limits. We'll talk about some of those today, actually. Okay. I don't know if I'm going to talk about OOP today. We will see if we have time. So quick aside, what makes learning a new spoken language hard? So maybe some of us can relate to this. Grammar can be really different between languages, right? So if I'm learning Italian or if I'm learning a completely different language from English, there might be weird grammatical differences like definite or indefinite articles. There's lots of different ways to say one thing to accomplish, saying one thing. So idioms can be kind of hard to understand if you're not native to a language that you're learning. Vocabulary is different. We describe things in different ways. And the alphabet is sometimes different too. So the symbols. Luckily for us, learning a second, third, fourth, etc. programming language is not that hard. So the grammar of most languages is super similar. That's really nice. Idioms can be a challenge in new languages, and some good fraction of our time with Python will be learning some of Python's special idioms, especially for working with lists. There's a lot of cool stuff there. Vocabulary does vary, but again, nowhere near as big a difference in learning an entirely different spoken language. Okay. The alphabet is different. So in Snap, we deal with blocks, we drag and drop blocks, but in Python, we're typing. Which is a little different. There's a little bit more room for error if you have too many spaces somewhere. If you have, well, less so with Python, but if you spell something wrong, Python is not as forgiving. So there's that. Questions about any of that? Brief little intro. Hopefully you're feeling comfy and okay to go on into Python. Anything? Okay, cool. So some simple translations. This is where I think it's good to start taking some notes about what you see difference-wise. But don't get too caught up. Mostly just look up here and listen to me. So first of all, to get us into the Python language, we're going to translate a couple programs from Snap to Python. And we'll make notes about how they differ. Here's a list of kind of what we're going to do agenda-wise. Okay. First of all, we run Python from the command line. So I don't know if you've ever seen, if you're a Mac user, you have something called terminal. Can't remember what it's called for PC. But that black little box that appears and that like looks like the hacker stuff from the movies. What was that? Command, was it? Command prompt on PC? Okay, yeah, that's what it is. Sorry. Yeah, so you're going to be using this for Python. And you'll see it's actually not too bad. You're going to do it in lab. And there's also other ways to run Python that we probably won't do in CS10. If you take did 8, you can see more of that. For Python, there are 2 modes. One we call interactive. So basically, I don't have to do much setup. I can just run Python in something called the shell, which I can demo really briefly. Oh gosh, let me switch over my sharing. Okay, make my font bigger. Okay, so here's this. I've got a command line. So again, you're going to pick all this up in lab. Don't worry about what I'm doing right now until I tell you. So I'm going into something called the shell. I don't have to define functions in here. I can kind of use it almost like a calculator. I can make variable names. I can append to things. I can things like that. So this is the command line, and you're going to learn what you're going to use this for in a bit. But that's what that looks like. It's called the Python shell. It's in the command line. Okay. Back here. Where did my, okay. Back again. Okay. Yeah. So that's one of them. There's also normal. So we can give a program a name, and then we use what's called an interpreter to run the code. So it's going to read what you typed out and then execute it. This is just like what we do when we press the green flag in Snap. So that's kind of the equivalent there. And you'll find as we go on today that there's a lot of things where you can draw lines exactly between what Snap and Python do, and a few where you can't. Something kind of basic. So I have a script here. I'm going to give you a sec to look it through. Mostly just passing in some variables via a script and then doing some stuff with them and then saying something. Okay. So the way I write this in Python looks like this. So I'm doing some assignment. So instead of set x to 10, I just say x is equal to 10. Y is equal to 20. And then I want to set up these new variables, give them the same names. And when I want to multiply, I do the asterisk. When I want to multiply some more, and usually in Snap, you'll have to put one multiply inside of another. And so you can just do this. You can do more than 2 when you're doing operators. And I can add. So hopefully this kind of makes sense. It's kind of intuitive. It's very nice and simple. And then I can do something called print, which is going to do the same thing kind of that Snap does when we do say. So that's just going to give me back what the value in R. Okay. In Snap, every piece of code is part of a sprite. So you've probably noticed by now that you kind of have a sprite on the right-hand side of the screen. When you make a new sprite, the stage goes blank because each piece of code belongs to a single sprite. That's not the way it works in Python. We just have some code and I, the programmer, run it when I want. Questions about this? Yeah.
So for Python, you don't even have to do like the set x equal to or certain variables. You just write the text that
Yep.
equal.
Yep. And this is a bunch shorter too, right? Because I don't have that script in there, right? Yep. I can just say this guy is a new variable and this is what he is. So that is declaring and assigning in one line, which is pretty cool. Yeah. Okay, any other questions? Do you have one back there? Can you say that one more time?
Does that also mean later part of the code you put this variable?
Good question. So the question is that, like, can I not use like X for a variable name again? So the answer to that is actually that I can use X again. It'll remember that it's 10. If I want X to have a different value, I can assign it, but then 10 will be lost. So it just remembers kind of X as a variable name, and then it'll say, okay, well, you know, they're assigning it to another value if I do something like that. Yeah, good question. Any others before I move on? Yeah.
So Python is a single equal sign denotes like an assignment with a double one.
Yeah, good question. So the question was about like equal signs. Sorry, I'm repeating for the recording because I don't know if your voice is, they can hear it from there. But the question is about equal signs. So does one mean assignment and does two mean equality? Yes, and I will get to that in a sec. Yeah, for this slide, yeah, one equal sign is just assignment. But sometimes it's also, if that's the first time we're seeing the variable, it's declaration and assignment. Yeah, good question. Any others? Okay, moving on. Cool. So here's another one. I love Josh Hug's function names. This one's called glorpify. Take a look at this real quick. It's not really doing anything special, just some computation. So we're taking in X and Y. We've got script variables X2 and Y3. Setting x2 to x squared and y3 to y cubed, and then we're adding that and reporting that. How might I write something like that in Python? Like that. And again, notice how much cleaner. So I use this keyword called def. Okay, if it lights up, that means it's a keyword, what we call a keyword. So you'll notice that return is the same way. So we def glorpify, which is the name, and then I have two parentheses, and in there I put whatever I want to be passed in. So I'm going to say X and Y are the ones I pass in. I use a colon to denote the end of my definition. And then I indent all the code underneath that so it's readable. So I define X2, I define Y3, and then I can return them summed. So notice that report becomes return. Kind of a note, maybe you're kind of watching this and you're wondering what this is going to look like for you. So you're going to use what's called a text editor. You know, I think my preference is Atom. Some people prefer Sublime. You can use what you like for the most part, as long as it's not going to cause too many issues on your computer. And what it will do, a lot of them, if they recognize the language, so in particular, for Python files, they will end in .py. You don't need to know this, I'm just kind of explaining. But if it recognizes that, it'll light up the keywords so it's easier to read your code. Kind of a cool thing. Yeah. So if I do something like this, say glorpify for 2 seconds. So what does all of this look like in Python? If I do print, and then I can do parentheses and then glorpify of my variables 10 and 20. Okay. Functions are defined in line. And then, yeah, our code has to be indented so that that's kind of like an important syntax thing, is that our interpreter has to be able to understand where our function is defined and where it stops being defined. But this is a function definition. This is me calling it. So this is me like pulling glorpify out of the side in Snap and putting my 10 and 20 in there. And then this is like saying say. So print and say are kind of the same things. Questions about that? All right, moving on. Defining functions and conditionals, okay? So, sorry, hopefully this is familiar. We can check to see if things are even by checking to see if their mod 2 is 0. And then if it's true, I can report true, otherwise I can report false. I can then do that in Python like this. So that same def is even. So notice, I think during the best practices lecture, I mentioned like coding, or sorry, naming conventions. So what I can do here is in Python, we will often just put an underscore. We can never have spaces in our variable or function names. So we do something like this to make it more readable, but you could not have the underscore there and it would be fine. It's just harder to read. So mod here is actually just a percent sign, just kind of funky. Notice again, yeah, so someone mentioned something about double equal signs. So this is now becoming a Boolean. So instead of the 1 equal sign, we have 2, and that denotes that that's going to be a true or false value. That whole statement with what's on the left and on the right side of the double equal sign. What's another thing that's different here between the two? Does anybody notice? Yeah. Yeah, that's a good one. So if I have an if and an else, it looks like if and else are lit up, so they're keywords. I have to have colons after each of those, and then I indent underneath for each thing that I'm going to do. Yeah, that's how I write if else's in Python. Yeah. Yes, mod is percent in Python. What else? What was that? We went over mod really fast. What was that? Yeah, parentheses here for putting my parameters in. Yeah, that's a good one. What else? Yeah. Yeah, return instead of report. And again, another keyword. Haven't found the one I'm looking for yet. Yeah.
Underscore.
Yep, that's another one, the underscore. What else? Yeah. Yeah, just def here. There's nothing here, but in Python we have to put def. Yeah. Another one. Yeah. Yep. Each line of the code is indented. I still haven't found the one I'm looking for. Yeah. Yeah. What was that? There's the 2 equal signs. Yeah. What else? We had that one. Yeah.
The T and the F are capitalized.
Yes. Yeah. True and false are case sensitive in Python. Weird one. So you notice that these are totally lowercase. It will not recognize true if you do not write it just like that. So notice if I want to do some, see what's true and true, do something like that, it's going to go, what are you talking about? So I'm not sharing this, I realize, but once I capitalize these, it knows exactly what I'm talking about. True and true is true. I can't remember if I have an example in here, but again, you'll learn all of this in lab and discussion, but our Boolean operators are just written as is, no caps, just like that. And or not. But yeah, gotta capitalize those guys. You'll notice that also like this doesn't work. Does not know what I'm talking about. Okay. Yeah. Another one is that we use hash signs for comments. I'm hoping I have an example of that in here. If not, again, you'll see in lab. Yeah, I think we got them all. Anybody seeing anything that I haven't mentioned yet? Excellent. I'll move on. Okay. So there's an even better approach here. Something kind of cool in Python. This is we can do the same thing in Snap. Is I can do this all in one line. So I can just say like whatever the value of this operator is going to be what the answer is to this, what I want to report or return. So it becomes increasingly easier once you start noticing these things, and also just as you start coding in Python about how we can make our code cleaner. And while that's not the top priority in this class, it's definitely something we'd like you to take away from this. Questions about that? Why that works? Cool. Moving on. User input. So hopefully you found out in homework 1 and homework 2 how we can take user input. This fancy little blue block. I say I ask a question in there and then I wait. And then whenever I run this code, where we say ask, there's going to be some text on the screen, and then it's going to prompt the user of the program for some input. And then that input will go into the answer variable, which is available on that tab. And then we can use that as data. So as input to our data, or sorry, input data to our program. Does anybody have questions about that? Hopefully you recognize it. Okay, so what's the equivalent? I actually didn't know this until I saw these slides. But you can use something called input in Python. And what will happen is when we set that equal to a variable, I can then use that as data. And it'll ask when I run it, what's your name? The user will be able to put their name in, and then I can use that. So I guess as you can gather from what I just said, like there are multiple ways to do this, but this is a really cool, convenient one. Yeah, question back there. What would be, can you say that one more time? If I do that, so if I say name is equal to what's your name, it's just going to set it to some text. So it's not going to prompt the user for input. Yeah, good question. Anything else? Any other questions about this? Yeah.
How did you find the answer to what's your name?
It's some good old abstraction. So that's a predefined function. And we have those already default in Python. We just can't drag them out like we can in Snap, but we kind of just have to know about them. So kind of this is us telling you, and you'll hear it more times about different functions, but that input works a certain type of way, and I can abstract away how it works and just know that it does. So when I call that function, so I call a function by saying like the name of it and then putting in whatever parameters it takes. So in this case, it being a string that I ask the user, and then it will just work. And you can also look up things like documentation to find out if you're more curious about how they work, because that does exist. Yeah.
Can I use input for all kinds of data? Like could I also ask for an age or a Boolean value?
An age or a Boolean value? Probably not. I can do something where I look up documentation. This is one of the most useful things I can do with Python code, is I can see what these default existing, as I say blocks, but functions in Python do. And I can see what their domain and range is. And that's part of why we emphasize this so much in this class, is knowing exactly how certain functions work and that I can't put in certain types of data into certain functions. So I'm not aware. We could definitely talk about that if there's time. What's that?
Input always returns a string.
There you go. Yeah, but that's a good question. And we're going to actually get into like kind of type conflicts in a sec here, because that's a really important part of moving into Python. Let's see, anything I've missed? So in Snap, the answer put into a special global variable called answer. So that's how input works there. In Python, the input function is essentially a reporter. So it works the same way in Snap. It's a command that sets the special global variable called answer. In Python, we don't have a notion of saying something for a certain amount of time. We just print and it'll show up somewhere and stay there. And again, you will see that in lab. We can also join strings by adding them with a plus sign, which is kind of cool, as you see here. Can't really do that in Snap, at least the same way. Okay. Yeah, the question?
This may be a bad question, but what if you use like
That's like a really good question. There's some really cool features of Python that you'll pick up on, but I can do something kind of like that where I like multiply it, which is kind of weird because you wouldn't like, we multiply numbers, right? Not text. But there are some things where certain functions are what's called like overloaded. And then you can use those symbols for multiple things. So if I do something funky like that, it'll do that, which is kind of cool. Again, that's kind of just something you pick up along the way. Nobody hands you I mean, we can, but it doesn't really work to hand you a manual and then just have you study that. It's more like, what do I need to do? What kind of function do I need to carry out right now? Does that exist? Quick Google search. In case you didn't know, professional software engineers totally use Google all the time. It's something called Stack Overflow. That's part of the job, which is kind of a cool outlook. I think sometimes in school, we have this concept where you need to memorize and know everything at all times. But it's much more reasonable to say, like, I have the skills to go get the information I need. And then I have access to it when I need. Anyways, that's my little rant about that. Any more questions about what's up here, about input? Yeah.
Not a question about the input, but the self-check.
Oh. Oh, can you set that to publish? Thank you. Yeah, we'll fix that right now. Sorry about that. Okay, you should be able to reload in a sec here once Diksha does that. Lists. Lists get really cool in Python. Couple of things here. So I have some code. I have a list called sum list. I can say the first item. I can say the list. I can check to see if it contains 7. Those are some things I can do in Snap. Turns out I can do them all in Python as well. So I can set a list like this. So lists use brackets, and then we just put items in there, and we define it just like we do any other variable in Python. Okay. I can print the first item. So I'm not going to go too much into this because we do a lot of that in lab and discussion, but Python uses something called zero indexing. What does that mean? Let's see, sorry. Let's say I have a list containing some words. Everybody see the board okay? I think these lights should help. Okay. So in Python, instead of going, this is my first item, this is my second item, this is my third item, we do something called zero indexing, which means we kind of shift that over. So we start everything with 0. So this becomes the 0th item, this becomes the first, and this the second. Kind of funky, kind of irritating at first, but you will see why, or maybe you won't right away. About why we do this, but this is actually the case for all programming languages like used in industry, is that everything is 0 indexed. Everything starts at 0. So the first item, I can call that by putting brackets at the end of some list, and that'll give me the first item. So this looks really different from this. So kind of take a good look. Okay, make a good note. All right. Python lists are created using magical symbols. So the square brackets, not parentheses, important one. I hope you're seeing what I mean when I say that there's a little bit more risk involved with Python, because you could accidentally mistype something, not know it while it's happening, and then your code will error. So something to note. You also do this cool operator called in, where I check to see if an item is inside of a list. So that thing here where I say is some list, if some list contains 7, instead I can say if 7 in some list. What I really like about the keywords in Python is that they make a lot of sense. It's not always like this, but Python in particular is super readable, which is very nice. You probably could have guessed that if I hadn't told you, just looking at this code, which is very nice. It's also nice when you're first learning Python and you have to read Python, is that you can just start to learn it by kind of making some guesses about what some keywords do. Questions about this, about lists? I apologize if this lecture is a little bit monotonous. It'll be very exciting when you actually get to do some coding, but this is just to give you some exposure, and so things start looking familiar in lab and discussion. Moving on. Lists and hops. So these get pretty cool. We're going to do this in a different lecture, but there's something called list computations where I can, what are they called? What am I looking for? List comprehensions. Thank you. Totally escaped my brain. List comprehensions are super cool. We're going to learn about that in a later lecture. But for now, you can use a map function in Python that works exactly the same as snap. So I can put in the name of a function. So in this case, I have square, which I've defined, and then I can just put that into map as the first argument, and then my list as the second. And it'll do exactly what map does in Python. So it takes in snap, it takes a function in a list and outputs a list. Pretty cool. Questions about this? Downtime, awesome. I think this is. Any questions? Okay, awesome. Okay. Some trickier translations. So that was kind of some of the more simple stuff in Python. Some trickier stuff when it comes to this transition between Snap and Python. So far we've seen programs that translate almost literally between Snap and Python. It's not always that easy. There are a couple of examples of where that's a little different. So where there aren't really those, draw the line equivalents between the two languages. So I'm just going to introduce some of those. Okay. So slice notation is a pretty cool Python feature that is not available in Snap. What this does is, so take a look at this program right here, and someone tell me what it does once they've read it. What does it do? Yeah, so we get a new list that is going to contain some range of values from the previous list. There isn't really a single operator that does this in Snap. We can grab like the 4th item, or I can grab the 1st item. But in Python, there's this really cool feature. So imagine I have like 100 items in a list, like numbers 1 through 100. If I want to grab like 25 through 75, there isn't really an efficient way to do that in Python, or sorry, in Snap. But in Python, I can do something called slicing. And what I can do is put the number of the index of the 1st item I want through the number through the index that I want. But this is something to note is that this is exclusive. Okay, so this gives me, so if I have a 1 here, where do I want to start in my list? From this list. 10, right, because we're 0 index. So this is the 0th item. This is the 1st item. So I want to start at 10. And where do I want to end? 40, right. So I have 0, 1, 2, 3, 4, 5, but this is exclusive, so I'm not going to include 50. Hopefully you have some knowledge about inclusive, exclusive bounds from math. If you don't, this is easy to pick up, but it's helpful here. So slicing from 1 to 5 is going to give me 10, 20, 30, 40. And I can print those. But this is, again, a lot cleaner than what's on the left. Okay. So this is how I can grab chunks of the middle of the list. Okay. Questions about slicing? Kind of convenient. Nice feature. Can't really do that in Snap in a clean way. Okay. This is kind of what I just said. This is slice notation, a little bit more specifics about it. So again, there's 0 index. So whatever I start with, I'm gonna is going to be the 1st one, that 1st argument. And then the left one is inclusive, the right is exclusive. If you omit an index, so if you just have a colon there, for example, instead of the 1st one, it'll just grab everything from that side of the list onwards until our endpoint. Again, don't worry about the exact details today. You're going to practice it later. Something to know. Look through these slides as well. This is kind of a cool slide to read. Definitely recommend it. Moving on to types. Okay, so you may have heard myself or Dikisha mention types a lot, and we don't really specify what that means a whole lot in the first half of this class. But types are less important in Snap. They're really important when they come to a lot of text-based languages. So essentially, when I say types, I'm talking about different types of data. And hopefully that concept, at least when I say that, is familiar. But right, I can have things like numbers, and I can have things like text. We call text strings in Python. Again, that'll come up later. But there are things like I can't do because it just doesn't make sense. Like I can't add the number 5 to potato. I can append them together and make them one string, but there's no way I can computationally add them because you don't do that with numbers and text. So there becomes this concept that's really important about like making sure that our data is the right types. Another reason why we really wanted to give you this idea of domain and range, because when I put the wrong type in a function, my code's just not going to work. So knowing that about your data beforehand and making sure that you're not putting the wrong types into the wrong functions is really important. Okay. So looking down here, this code is not really possible in Snap. We can't ask for the type of a variable, but I can do this in Python. So something kind of interesting here is I can define something like a variable, make my thing a little bit bigger. So if I have something where I have a variable called x and it's cat, I can ask for the type. So again, another predefined function in Python that I can just use, and it will work. And I know that because I've had lots of practice with it. And what it tells me here in a funky kind of way with carets on the end is that it's of the string class. So it's text. I can do the same thing if I have a number. So if I say, what's the type of 5? Well, it tells me it's an integer. Kind of neat. And hopefully maybe you can think of some examples where that might be actually really helpful. Okay. There is, I think, something in Snap where we say like is like blank variable a number. That's kind of similar, but we don't really have an equivalent in terms of asking for type in Snap. So another cool feature. Okay. I can do this thing called conversion, like converting types in Python. So as you just noticed, we have like str and int. So those are the names of the classes or the data types that these variables belong to. So I can actually use those names to convert them. So I can do something where I have like, let's see. Oops. I have a number. I can actually just make that text by putting str around it, and suddenly it's a string. So it's no longer looked at as a number. So I can't just add something to it. So if I set this equal to, the num is now a string, I can't just go adding 5 to it. Because again, we have that idea of conflicting types, and I can't add strings. Okay. We don't totally go into types in this class, but it's certainly important when it comes to things like the domain and range of functions. Okay. I actually think I'm going to stop there because we have a whole lecture dedicated to object-oriented programming. Yeah. Does anybody have any questions? Yeah. Tuples. I don't know if we ever explicitly go over tuples. Is that right? Yeah, I'm not sure we do. If you're curious, because we have time, tuples are immutable. So they're not lists, but they're collections of data. So I can do something like this. D is now a tuple, but I can't mutate it like I can a list. If you don't know what that means, don't worry too much about it. You're welcome to come up and ask questions. But yeah, a tuple is definitely a data type in Python. Any other questions before I finish up here? Everybody like Python? Yeah, what's up? What's a tuple? It's what I just described. It's just a data type. Looks like this. Instead of having square brackets around it, it has parentheses around it. I don't really believe we'll use those in this class, so you don't really need to worry too much about that. But if you're curious and want to use it for yourself, you may. Lab will go over installation of text editors in Python itself. So once you do that, you're set to play around with Python. I really, really would encourage you to open up Python. Again, you'll learn how to use the shell in lab. But once you learn to do that, take advantage of that. If you have questions like, what happens if I do this? What happens if I do that? Nothing bad will happen if you go open up your terminal and test it out. So please, please play with code, test it. Like that's like the whole fun of this. So yeah.
Do you use Python 3 or just Python 2?
I think it's fine. Yeah, I think you're fine. No matter what. Huh? Yeah. Yeah, I think Python 3 is probably preferable. If you have questions about installing that, you're welcome to come to office hours. Yeah, cool. Vinaj. Yes. Yeah. Yeah, 3 is definitely preferred. Yeah. Welcome to come up and ask questions or whatever you would like, but I'm going to end there. Yeah. Thanks, guys.